and welcome to my YouTube channel, where basically every episode I take a physics topic and hopefully explain it in a really simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. This episode is just a fun physics fact episode. Woo! Today I'm going to be telling you all about superconductors. Now, if that didn't make it sound cool, then heads up, they are! Materials can be divided into two categories based on their ability to conduct electricity. Metals, like copper and silver, allow the electrons to move freely and carry electrical charge with them, whereas insulators, like rubber or wood, hold onto their electrons tightly and will not allow an electric current to flow. So yeah, that's the difference between a conductor and an insulator. Now, in about the 1910s, so just over a century ago, scientists were experimenting with conductors to see how they behaved in extreme conditions. Now, one of these conditions was cooling the conductor to absolute zero. Now, this is 0 Kelvin or minus 273 degrees C. Absolute zero is the lowest possible temperature where nothing could be colder and no heat energy remains in a substance. So you cannot get colder than minus 273 degrees C. We're learning so much! So, these scientists were experimenting with how conductors would behave at absolute zero. But we haven't actually been able to reach absolute zero yet. However, we can get close to it by using stuff like liquid nitrogen and liquid helium, because they can get to temperatures of about minus 210 degrees C and minus 260 degrees C. Close enough. When performing these experiments, scientists noticed that when cooled to extremely low temperatures, some of the simple elements like mercury and lead could conduct electricity with no resistance. So now, these types of materials are thought of as neither a metal nor an insulator, but some exotic third category called a superconductor. A superconductor. Okay, I'll stop that now. But they conduct electricity perfectly because there's no resistance. This means an electrical current in a superconducting wire would continue to flow round in circles for billions of years, never degrading or dissipating. Wow! Limitless electricity! For a normal metal, there is always a resistance, whatever the temperature. But for a superconducting metal, when it reaches its critical temperature, the resistance suddenly drops to zero. Poof, just like that. One interesting and potentially useful property of a superconductor arises when they're placed near a strong magnet. The magnetic field from the magnet causes electrical currents to spontaneously flow on the surface of the superconductor, creating its own counteracting magnetic field. Ooh. The result is that the superconductor or the magnet can dramatically levitate, suspended in the air by an invisible magnetic force. I did my dissertation on high temperature superconductors. I'll explain a little bit about what these are later, but here's a video of a superconductor I made with a magnet floating above it. Wingardium Leviosa. It is literally like Harry Potter, and it is so cool! So the thing that prevents us from using superconductors in day-to-day life is the fact that they operate under such low temperatures. In the simple elements, superconductivity stops working at about 10 Kelvin, so like minus 263 degrees C. It's a bit chilly, that. Therefore, scientists are working on producing high-temperature superconductors. Sorry, I'll stop now. These involve more complicated compounds and attempt to get superconductivity to work at higher temperatures. At the moment, we've achieved up to about 100 Kelvin. but that's still minus 173 degrees C. Now it's an improvement, but it's still colder than the coldest night in Antarctica. Alas, we're still dreaming of the day that we could get superconductors to work at room temperature. The possibilities would be endless. I'm talking ultra high speed trains that float on magnetic tracks. I'm talking hoverboards, Back to the Future style. There you go. I hope you know a little bit more about superconductors than you did before this episode. Thank you so much for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I will try to do a video for you.